Okay, so good morning to everyone. This is Janelle, and I'll be the moderator for this session. So this would be our last session for the Jointless Steel Fiber Concrete series. So today, our webinar will focus on the installation and maintenance of the jointless steel fiber concrete. So I'd like to thank everyone who are here today, and of course, a big thanks to those who were able to attend our previous session. So for those who were not able to attend the previous sessions, you may visit our YouTube account to watch the full webinar recording. So again, we are glad that we have you all here today, and we hope you will find this webinar valuable and informative. So before we begin, I have a few items to mention. So if you have questions, you are welcome to type them on the chat box, and we'll bring them up during the Q&A session. So this session will be recorded. You will also receive an email with the presentation slide as soon as we have it ready for you. So make sure that you have used your complete name upon joining this session for identification. I will send you a few feedback questions about this webinar, and of course, e-certificates will be available upon request. I will share the survey and e-certificate request link into the chat box before the session ends. So make sure that you have accomplished the form. Releasing of certificates is within 3 to 5 working days. I repeat, 3 to 5 working days. So please check your email within this period. And again, certificates of attendance are applicable only to those who attended this session. Also, we would like to invite everyone to connect with us on our social media accounts, Facebook, LinkedIn, and YouTube. You may follow us and get updated on the latest news and events. So for questions or inquiries, you may contact us at sales@infratexenviro.com or through our mobile and telephone numbers. You may also visit www.infratexenviro.com to know more about our products and solutions. Joining us today is Engineer Gilbert Ancheta. He is a licensed mechanical engineer and he graduated from Polytechnic University of the Philippines. He has extensive experience in the implementation of various projects from delivery, installation, testing, and commissioning. So currently, he is the Infratech sales engineer for jointless steel fiber concrete reinforcement. So that's it for our introduction. I will now turn the time over to our speaker. Hello, Gilbert.
Hi, ma'am. Thank you for the introduction. So, good morning, everyone. Thank you and welcome to the part 3 of this webinar series. So, are you seeing my screen now?
Yes, Gilbert.
So, before we start, let me first acknowledge the presence of our partners. So, joining us today is Mr. Peter Chan from Beckart. So, he's all the way from Kuala Lumpur, and Mr. Dimitro Triaskin from PECO, who's based on Shanghai. So thank you guys for also joining us today. So in today's session, we'll be discussing the installation and maintenance of jointless steel fiber concrete solution. But before we start, let us first recap the things that we've discussed in the previous session. So in session 1 and 2, we learned the benefits of using the steel fibers and armor joints or terra joint in floor construction. So steel fibers eliminates the traditional reinforcement that makes the construction faster and safer. It also provides homogeneous distribution of reinforcement on the concrete structures. It distributed the it redistributes the stresses, making the floor with high ductility and increased load-bearing capacity. Steel fibers also provides an excellent crack control that reduces the concrete cracking and spalling on segments. While in using Terra joint, we were able to do large bay casting that reduces the construction time and provides savings on maintenance costs because the areas are protected at construction joints. So for this session, we'll be discussing the construction methodology of jointless steel fiber reinforced concrete floor. So this presentation includes the preparation of the soil, terra joint and terra dowel installation, the dosing of steel fibers in concrete mix, pouring of steel fiber in reinforced or pouring of steel fiber reinforced concrete, other concreting process, and at the end we'll have a question and answer session. So to begin, just like any other type of construction methodology, it starts with the preparation of the soil. So the sub-base must be prepared in accordance with the project specification. The soil must be well compacted. So remember that if you do a backfill sub-base where it is done in layers, each layer must be compacted as required on the spec. So for example, we have here a 3-layer sub-base. So layer 1, layer 2, layer 3 must be compacted as required on the spec. So for example, the specs requires a 95% compaction. So each layer must be 95% compacted, not just the top layer, not just the bottom layer, but all of the layers. Next point is to make sure that the soil is flat as much as possible, at least a flatness tolerance of plus or minus 10 millimeters. So as I mentioned during the first session, good thing here in the Philippines is that mostly of the constructors follow a stricter flatness tolerance of plus or minus 5 millimeters, which is actually better. But for the sake of consistency within the presentation, I'll be using plus or minus 10 millimeters because it follows the range wherein the terra joint can perform. Last point is to make sure that the sabi is dry and there's no water punts. So of course, we don't want too much moisture penetrating the slab and cause oxidation or corrosion and cause spalling of segments in the floor. So here I have a sample of the things to avoid during the soil preparation. So number 1, as I said, are the water pans or the wet sub-base. Number 2 is rotting or soil depression from the heavy equipment present at site. So soil depression usually indicates that there are soft spots or weak spots on the soil. So these soft spots are the usual failure on your concrete floor. So it eventually causes deep cracking on the floor. So as soon as you notice soft spots or depression on the soil, make sure to recompact the soil as required on the specs. While on the other hand, we have a sample of a perfectly prepared sub-base. So as you can see, the soil is dry, there's no water ponds. Even that the mixing trucks entered this area, it does not create soil depression, indicating that the soil is well compacted. Open areas are also temporarily closed to protect the soil and the freshly concreted slab against rain. It's also a good practice to use plastic film sheet as an extra layer of moisture protection, and also it lessens the friction between the soil and the slab when the slab started shrinking. After the preparation of the soil, the next step would be the terra joint and terra dowel installation. So here I have two joint layouts. So the left one uses a combination of terra joints and terra dowel as a cheaper option. So the green lines represent terra dowel and the blue lines represent, the green lines represent terra joints and the blue lines represent terra dowels. So mostly terra dowels are placed on joints underneath racking system or joints wherein most of the traffic are coming from foot traffic only, not from the forklifts. While on the right one, it uses a full terra joint system, which is more flexible in cases wherein the location of the racks are not yet identified. So these layouts will be submitted to the clients for their approval, and once approved, the position of each terra joint and terra dowel line must be followed as close as possible. So as mentioned on the previous session, the terra joints are normally 15 millimeters smaller compared to the slab thickness. So if the slab thickness is 200 millimeters, the terra joint height would be 185 millimeters. So the reason behind that is because we should maintain a 15 millimeter gap plus or minus 10 millimeter between the soil and the terra joint. This gap would provide, or this would allow the slab to move smoothly during its natural concrete shrinkage. So the 10 millimeter, this is where the flatness tolerance come from. So if you install the terra joint like this, wherein the soil touches the bottom of the terra joint, what is do it hinders or it blocks the movement of the slab during its shrinkage. So normally it causes the aris to separate from the top strip. So when they separate, the aris is prone to damages and we don't want that to happen. Now, since there is a gap between the terra joint and the soil, there's a risk of overflowing of concrete. So it is a must to remove that overflowed concrete while it is still wet, or otherwise we have to shift off hardened concrete, and that would be time consuming. Uh, in our previous projects, to minimize that, we recommend to use materials like pipes, the timber from the pallets of the terra joints, or even sand to block that gap. So after the concrete hardened, you can just easily remove that material. And in installation of Terra Joint, there's a device called TerraFix to allow easy and uh, quicker installation of Terra Joint. So it has several features. At the top, it has a bolt that adjusts the height of the Terra Joint. At the middle, it has a support tips and pin that holds the Terra Joint. At the bottom, it has a tapered fit to allow to provide stability and allow easy removal from any hardened concrete. At the other end, it has a hole that allows insertion of rebar or rebar pin and a bolt that lock in place the TerraFix and TerraJoint. So normally, we recommend to use 3 pieces of TerraFix per TerraJoint. So one at each end and one at the middle. However, if you're doing a very large base, say 30 by 30, it will require a lot of TerraFix. So for 30 by 30 base size, approximately you will need 120 pieces of TerraFix. So that could be a lot and expensive. So to minimize the number of TerraFix, we adopt another method of using rebar pins or pins. So from 3, we'll be using 2 pieces of TerraFix, one at each end, have the Terra joint adjusted to the right height and right straightness, then in between, support the Terra joint with rebar pins. So in using pins, make sure not to weld or not to fix the pins directly on the top strip, to the dowels or to the sleeve or to the divider plate. We can only allow fixing or welding of pins on the studs on this portion only, and it should be in between the dowels, not facing the dowels, because it may also block the movement of the slab. While in Terra dowel installation, the first thing you have to do is to prepare the timber or the formwork according to the slab height. So for example, we have a 200 millimeters slab 200 millimeter slab. So make sure you use a 40 millimeter timber or a little bit smaller, but not less than 20 millimeters. And the formwork should not be bended so that you can install the sleeve flat on the formwork. Then make a horizontal line at a height equal to 1/2 of the slab thickness. So in this case, at 100 millimeters. Then also mark the center to center spacing between the sleeve, which is ideally 500 millimeters apart. And before you install the sleeve, make sure to inspect each sleeve. So any damaged sleeve should not be used. The tape on the other side should, or the slot of the dowel should be properly sealed off. Any damaged tape should be replaced. And also take note that the first sleeve is 250 millimeters from your starting point. So from the walls or from the isolation joint of the columns. So please avoid installing the sleeve where it touches the isolation joints or the walls. Same case on the end of the teradawel line. So if there are cases wherein the sleeve is very near on the end of the line, say 100 millimeters or less, you can adjust the center to center distance between the last two sleeve to make the distance between the last sleeve and the end of the line between 200 and 250 millimeters. And if you're using steel formworks, you have to use small bolts and nuts. So ideally a wing nut and a screw of 40 to 45 millimeters. So first drill a hole on your formwork, then install the sleeve, making sure that the nuts or the wing nuts are on the opposite side of the casting. So after installing all the Terra joints and Terra dowel, you have to double check or to inspect each Terra joint and Terra dowel. Make sure that you have the correct height and right straightness. Any missed installed pins must be adjusted. So for this example, where the pins touches the top strip, you have to adjust it on this portion. After that, the next step would be the dosing of steel fibers. So you can do the dosing of steel fibers either at the batching plant or at site at the mixing truck. But it's highly recommended to do the dosing at the batching plant through the conveyors and central mixers because it will take less time in order to achieve the right amount of steel fibers per cubic meter of concrete. However, if there are cases wherein the batching plant is too far from the site, say the mixing truck will take more than 1 hour of travel time, it's best to do the dosing at site at the back of mixing truck. So in dosing at the mixing truck, the drum speed must be at high speed, the highest speed. Then after completely dosing the steel fibers, make sure to continue mixing for at least 5 minutes or 1 minute per cubic meter of concrete. So if you have 10 cubic meter of concrete, continue mixing for 10 minutes. After the dosing, you have to check the slump. So the slump would depend on the fiber dosage and how you're going to pour the concrete. So for steel fiber reinforced concrete with 20 to 25 kilogram per cubic meter, that if you're doing it by direct discharge, the slump must be 130 millimeters. For if you're going to use concrete pump, it should be 150 millimeters. For SFRC with fiber dosage of 30 to 35, by direct pouring, you must have a slump of 30 to 150 millimeters, and while using concrete pump, it should be 150 to 180. And for fiber dosage of 40 to 45 kilogram per cubic meter, both for direct discharge and using concrete pump, the fiber dosage must be between 150 to 180 millimeters. After checking the slump, we'll be doing a washout test. So the washout test is to determine whether we have the right amount of fiber per cubic meter. So this is actually based on British standard EN 14721. We take 3 samples into a 5-liter bucket, then separate the fibers from the concrete mix. So we separate them by vibration, washing out the mixture, then picking out the steel fibers and washing it again. Then the collected fibers will be weighed and the allowable result must be within the range of plus or minus 10% to allow it for pouring. So for this specific washout test, the fiber dosage is 20 kilogram per cubic meter. So for a 5-liter bucket, the theoretical amount of fiber is 100 grams. So after doing the washout test, we recorded a result of 98 grams, telling that the fibers are well mixed within the concrete. After that, you're okay to pour and level the steel fiber reinforced concrete. So using the trowels and other flooring equipment, distribute the SFRC within the bay. Then overflowed concrete on top of the strip must be removed and properly leveled. Make sure also to vibrate on the areas near the dowels and the sleeve. So make sure that the areas underneath the sleeve or dowel are completely filled with concrete. So there's no hollow points or there's no entrapped air. Then make sure to inspect also the areas around the joints, making sure that it is in level with the top strip. So that's very important because once the warehouse or the distribution center started operation, unleveled floor on joints are very dangerous for the forklifts. So this would be an example of a nicely prepared or leveled concrete on the Terra joints top strip. And in this case, wherein the concrete overflowed on the top strip, it normally causes excessive dusting and unlevelness on the joints. So just I said, which is uh, a more commonly cause of safety issues and forklift accidents. So make sure to avoid overflowing of your concrete on the top strip level. After that would be the screeding. So for doing large bait casting or jointless floor, it's very advantageous to use laser screed because it uses a telescopic boom and automatically levels the concrete surface, fast yet precisely leveling it at a rate of 240 square meters in just 60 seconds. After screeding, the next step would be to make sure that there are no floating or sticking out steel fibers on the surface of the concrete. So the best way to do that is by making or using mesh roller to depress or push down the fibers, including the aggregates. Then follow that, bull float the surface, to remove other imperfection. And also it helps you to prepare the concrete for chowling. I have here a video that shows the full process. So this is also a large bay casting that uses steel fibers and take Peco armor joints. Technical issues. Sorry for the technical issues. Sorry. Yeah, sorry for slow internet. So after a few minutes after bull floating the surface, you can proceed with the floor profiling to measure the F-min of the identified traffic route of the forklift. Then power tool or use a trowel to compress the top layer of the slab to create a clear and fine finish. Then after the concrete hardens and you're ready to pour on the other side, just remove the tape of the sleeve and insert the plate dowels. But before pouring, make sure that all the edges are clean and free from any rough surfaces. Now, that would be the whole process of SFRC floor construction. Now, going on the maintenance, we know that the joints are the weakest spot on the floor. So normally cracks started on the joints and it requires regular maintenance. So for joints without arist armoring, the joints normally chips off and creates cracking and cause accidents on the forklift or other safety issues. So in using SFRC and armor joints or Terra joint, these cases are minimized. So the iris are protected. So the usual maintenance to do is the once a year application of flexible joint sealant. So the sealants will avoid infiltration of water and other materials, and also it reduces the corrosion on the plate dowels. Also, to further minimize your maintenance, Pico offers another product, Joint Saver, which is a permanent joint filler, which is a compressed strip that remains in contact with the joint gap. This would be the sample of the finished floor. So taken from our ongoing Southern Star project, this would be the warehouse area. So after the 28-day curing period and the concrete reaches its required compressive strength, the area are okay to use as staging areas of other materials. Lifting equipment can also utilize the floor. Just make sure to use necessary protective materials like plywoods or steel plates. Also, we have this area on the loading bay or the loading bay area. So what we recommend on Southern Star is to have this portion a combi slab. So meaning it is a combination of rebars and steel fibers. So why is that? Because a loading bay area is considered as a busy area or a high risk area. So formation of cracks on this portion are greater than any part of the warehouse or the distribution centers. So in order to minimize that, to address that, we recommend to do the combi slab. So the combi slab eliminate the construction joints or the saw cuts, which also minimize the maintenance of the floor eventually. So this would be a more clear photo for that design. So this one uses a combi slab and it is separated by a Terra joint. So once, if there are chance that a crack forms here, it would not pass through on this area. So this would be a pure steel fiber concrete. Another area from Southern Star is the cold storage area. This also uses a combi slab because the challenge in cold storage is that when it started operation, it's very hard to repair, it's very hard to maintain. So in order to achieve a low maintenance floor, we recommended a combi slab so that the steel fiber will achieve an optimal resistance to thermal cracking, and also we lessens the joints. So joints are normally the main cost of maintenance. So the frequency would be lessened. Next one is taken from our Nestle warehouse project in Tarlac. So this uses a 20 kilogram per cubic meter of 3D fibers and Terra joint and Terra dowels. So the Terra joints on the forklift identified traffic route uses Terra joint for iris protection, and joints underneath racking system uses Terra dowel only. And last one is from the Japan Tobacco International Flex Facility in Batangas. So this is a large bay casting of 20 meters by 20 meters that uses Terra joints and steel fibers of 20 kilogram per cubic meter. That's actually ends my presentation. So if you have questions, we can answer you now.
Okay, thank you, Gilbert, for your informative presentation. So I hope everyone learned something valuable on it. So we will now go ahead and take some time for questions now. So just a reminder, please be sure to type your questions into the chat box. Thank you.